This lesson is on solving system equations using elimination, but there's going to be an extra step. When we first look at this, we notice that our equations are lined up, so I'm going to use elimination. But I notice that my x's do not have the same coefficient, and my y's do not have the same coefficients. So in order to get one of the variables to have the same coefficient, I can multiply both sides of an equation by a number to get them to be the same. The first number I notice is that this is a negative 4x, and with the x there's a negative imaginary 1. So I'm going to multiply this entire bottom equation by 4. My top equation stays the same. Negative 4x plus 9y equals 9. Now I have to multiply all three terms by 4. 1x times 4 is 4x. Negative 3y times 4 is negative 12y. Negative 6 times 4 is negative 24. Now, my x's have the same coefficient, but they're different signs. So I'm going to add my two equations. Negative 4x plus 4x is 0, so it gets eliminated. 9 plus a negative 12 is negative 3y. And 9 plus a negative 24 is negative 15. Divide both sides by negative 3. Y is equal to 5. Now to determine what x is, I'm going to substitute back into one of my original equations. It's always best to substitute into your original equation in case you made a mistake multiplying by changing one of the equations. I'm going to pick the bottom one because the x is by itself. So I have x minus 3 times 5 equals negative 6. X minus 15 equals negative 6. Add 15 to both sides, and I'm left with x equals 11. So I write my final answer as an ordered pair, 11, 5. Solve this system using elimination. Since their equations are lined up already, elimination would be my best option. I check to see if any of my coefficients are the same. I have a 5x and a 3y, so they're not the same. 4y and 9y, also not the same. So I have to multiply one of the equations to get them to be the same. It's always best to multiply by an integer so I don't have to deal with fractions or decimals. I notice I can't multiply 3 by anything to get 5, and I also can't multiply 4 by anything to get 9. So in this case, I have to multiply both equations. I'm going to pick the x's to get them to be the same. So I have 5x and 3x. So the least common multiple of 5 and 3 would be 15. So I'm going to multiply the top equation by 3, bottom equation by 5. So this gives me 15x plus 12y is equal to negative 90. And the bottom equation, 15x minus 45y is equal to negative 90. Now, my x's have the same coefficient and they're the same sign, so I'm going to subtract my two equations. 15x minus 15x is 0. It gets eliminated. 12 minus a negative 45 is 57y. And negative 90 minus a negative 90 is 0. Now I can divide both sides by 57, and I'm left with y is equal to 0. Now to determine x, I'm going to substitute back into one of my original equations. I'm going to pick the bottom one just because the 3 is smaller. So I have 3x minus 9 times 0 equals negative 18. This just leaves me with 3x equals negative 18. Divide both sides by 3. X is equal to negative 6. So my final answer in ordered pair would be negative 6, 0. Which system of equations has the same solution as this system? So one way I could do this is I could solve the given system and then solve all 4 of the other ones and see which one gets me the same solutions. But to make it a little easier, I can just see which one is multiples of the other equations to match them up. So if I look at answer choice A, or 1, 2x plus 2y equals 16, 2x plus 2y equals 16. Those match up. Now I'm left with 6x minus 2y equals 4. That doesn't match the bottom equation because it looks like it's multiplied by 2. But if I have 3x minus y equals 4, and I multiply it by 2, I have to multiply everything by 2. So it should be 6x minus 2y equals 8. So answer choice 1 is not correct. Answer choice 2, I'm left with 2x plus 2y equals 16, matches the top equation. My bottom equation, 6x minus 2y equals 8, which is just my bottom equation from the original problem, multiplied by 2. 6x minus 2y equals 8. So 2 looks like it's good. I'm going to check the others just to be sure. Answer choice 3, I'm left with x plus y equals 16. If I double that equation to try to make it match the first one, I'm left with 2x plus 2y equals 32. But in my given equation equals 16. So 3 is out. For 4, 6x plus 6y equals 48. If I take my top equation and multiply it by 3, I'm left with 6x plus 6y equals 48. So that one matches. But the bottom one is 6x plus 2y, but it really should be 6x minus 2y equals 8. So 4 is out. So 2 is the only one that's left and would have the same solution as the given system. Julia went to the movies and bought 1 jumbo popcorn and 2 chocolate chip cookies for $5. Marvin went to the same movie theater and bought 1 jumbo popcorn and 4 chocolate chip cookies for $6. Write and solve a system of equations to determine the cost of each. So first, before I write my system, I'm going to identify my variables. I'm going to use P to represent the price of the popcorn, and I'm going to use C to represent the price of the cookies. So now I'm going to write my equation for Julia first. She bought 1 jumbo popcorn, so that's 1P, and 2 cookies to equal $5. Now for Marvin bought 1 jumbo popcorn, so 1P, and 4 chocolate chip cookies, 4C, for $6. Now I notice they're lined up, so I'm going to use elimination. My P's have the same coefficient and they're the same sign, so I'm going to subtract my 2 equations. 1P minus 1P is 0, so it gets eliminated. 2C minus 4C is negative 2C, and 5 minus 6 is negative 1. So I would divide both sides by negative 2, and I'm left with C equals 0.5. Now I have to solve for P. I'm going to use my top equation. P plus 2 times 0.5 equals 5. P plus 0.5 times 2 is 1 equals 5. And I subtract 1. P is equal to 4. And since it's a word problem, I'm going to give a word answer and say cookies cost 50 cents each, and the popcorn cost $4 each. Last problem. 2 scout troops went shopping for camping supplies at the same store. The first group spent $299 on 7 flashlights and 11 sleeping bags. Second group spent $304 on 8 flashlights and 11 sleeping bags. Write and solve a system of equations using elimination to find the price of each flashlight and each sleeping bag. So first, I'm going to identify my variables. F is the price of the flashlight, and I'm going to use B, because I don't like to use S because it can look like a 5, for the price of the sleeping bag. So the first group spent $209 on 7 flashlights and 11 sleeping bags. So that's 7F plus 11B is equal to $299. And the second group bought 8 flashlights, so that's 8F, and 11 sleeping bags, so 11B, for a total of $304. Using elimination, because the equations are lined up, so elimination is best, I noticed that the B's have the same coefficient and they're the same sign. So I'm going to subtract my 2 equations. 7F minus 8F is a negative 1F. 11B minus 11B is 0, so that cancels out. 299 minus 304 is negative 5. So I divide both sides by negative 1. F is equal to 5. Now, to find B, the cost of the sleeping bag, I'm going to substitute in. So I have 7 times 5 plus 11B equals 299. 35 plus 11B equals 299. Subtract 35 from each side. 11B is equal to 264. Divide both sides by 11. B is equal to 24. So I would say that each flashlight costs $5, and each sleeping bag costs $24.